This video will talk about the distributive property. So what I'll do is I'm going to write out a couple examples, and you'll see to my left the calculator that you are using in class. This is actually the TI-84 plus C silver edition. So this is the color version. It works very similar to the TI-84, just the regular one without the color, and also the TI-83. So I just thought I would change models so it matches some of the different calculators that are in the class. So remember, with this distributive property, you have a number outside the parenthesis, and we're just using generic letters right now. And then what you need to remember is that whatever's outside the parentheses, you need to multiply by the first term in the within the parentheses. So you're going to get AB, and then you multiply it by the second term. And then remember that terms are separated by plus signs. So then you would write down the plus, and then you have AC. So let's try an example with some numbers. And when you're doing this, you will always have a ladder. Otherwise, if you just had numbers in there, you could just put them in your calculator and go ahead and solve. But once we have a letter in there, things change. So what we do is we take the 5 times the 3y, and then we put our plus down, and then again we take the 5 times the 7. And then we take and multiply our numbers together, and 5 times 3 is 15. And if for some reason you didn't remember, you could put in your calculator. And then the next one is 5 times 7, so you could just do 5 times 7. Now, when the numbers are smaller, it's not a big deal, you can do them in your head, but sometimes the numbers get rather large. So I'd have my calculator sitting on the table with me, and again, use it as a tool. You don't need to use it all the time, but as something comes up, have it available so you're ready to go ahead and use it. So let's try another one. So we have 5 times 3x plus 7, which we've seen above, but then this time we're going to go ahead and add 6x to it. So what we ultimately want to do is combine like terms, and when you're working with this, the rules are in your book, and what you want to do is you want to use the distributive property to move the parentheses. So you can see we have parentheses here, so we want to get those removed first, and then we're going to rearrange the terms so we can put our like terms together, and then we're going to go ahead and combine them. So again, we're going to use our distributive property. So we're going to take 5 times our 3x, and this time we're using the letter x, and then plus 5 times our 7, and then the 6x is just going to come with. Okay, so then we're going to do the 5 times 3, which gives us 15x, plus 35, plus 6x. And then we're going to put our like terms next to each other, so there's x's in both of these. Now remember, like terms are x's, or eventually you might see x squared, x cubed, and then anything without an x, just a constant, would also be grouped together. And then we can see that since these are both x's, we can go ahead and add the coefficients together. So 15 plus 6 is 21x, and then the 35 comes down, and you're done. And as I mentioned in class, if you want to check this, you can just make up a number for x and try it and see if it works. So what I'm going to do is let x equal 2. So I have that written here. And then I'm going to go ahead and substitute in 2 for x in the 5x, which you can see here, times 3x plus 7 plus 6x. So you can see how I substituted the 2 in here. And then what I can do is go ahead and put it in my calculator. So you can see up here how I've entered 5 times 3x, or 5 times, in parentheses, 3 times 2 plus 7, and then plus 6 times 2, and I got 77. And then I take my simplified equation, and I also enter in 2. So I have 21 times 2 plus 35, and I also get 77. So for both of these, I get 7, and now I know that I have at least come up with an equivalent expression. So it doesn't tell you that you've completely simplified it. That will be up to you, but you do know that you didn't make a mistake when you were simplifying. So if you were to enter 2 into this equation, it would also work, as well as this one. But neither of these equations are in the final form. You'd have to make sure you continue to this form in order to be correct. So one last example. Let's go ahead up here, and we're going to use 6 times 2x plus 4y, and then plus 10 times 4x plus 3y. Okay, so again, we want to get rid of the parentheses. So we have 6 times 2x plus 6 times 4y plus 10 times 4x plus 10 times 3y. Okay, so again, what I did was 6 times 2x, 6 times 4y, 10 times 4x, 10 times 3y. And you don't have to necessarily do this middle step. I would do it until you're comfortable, and then once you're comfortable, you can go ahead and drop it and just go from here to this next step. So 6 times 2x is 12x, 6 times 4y is 24y, plus 40x, so 10 times 4 is 40, plus 10 times 3 is 30y. So you're multiplying 10 times 3y. And at this point, you can rewrite your like terms next to each other, or you could just add them together, and I would put a little check mark over them to remind you that you've used those terms. With 4, it's not so bad, but if you have more than this, sometimes you can lose track. So what I did was I put the like terms together, or again, you could take 12x plus 4x. So I have 52x plus 54y, and then I've got it reduced to its simplest form. So again, what you could do is you could let x equal 2 and maybe y equal 3. Again, I'm just picking numbers, and try them in this first equation and try them in this last equation. And if your results match, you know that you have an equivalent form of the expression that we're looking at. And again, all of these in the middle are equivalent forms, but we want the most simplified where all our like terms have been combined.